Today we're going to look at section 3.2b, writing systems of equations from word problems. And our goal is to be able to write a system given a word problem and eventually be able to solve it. So what are the steps for writing a system of equations? The main thing is to define your variables. And the big key is to make sure you use correct units. Don't just say x equals dog. Does x equal the cost of a dog, the number of dogs, the weight of a dog? You always want to give units. And also, thinking about what your category for each equation is might help you in order to make sure you put the right variables and the right units together. And I'll go through each one. So here's our first example. You purchased 10 bags of balloons and 6 rolls of streamers for $20.10 for a gas. You realize that this is not enough, so you go back. This time, you spend $12.80 on 4 bags of balloons and 8 rolls of streamers. What was the price for each item? So the first thing you want to think about is, what is the question asking for? That will help you decide what your variables should be. So since we want to know what the price of each item is, let's think about the item. We have bags of balloons, and I'm going to call that X. It's going to be the price, so it's going to be cost for a bag of balloons. And then the other one, we're going to use Y, just to make it easier, is the price for a roll of streamers. Okay. So now we want to write a system. So we have 2 unknowns, so we need 2 equations. If we had 3 unknowns, we would need 3 equations, 4 unknowns, 4, and so on. So let's think. We purchased 10 bags of balloons and 6 rolls of streamers for $20.10. So we have this total. Okay, totals usually help us write our equations. We have a total of money, so I know that 10 bags, and each bag costs X amount, plus 6 rolls, which cost Y amount, should give me a total of money. And we don't really use that. We don't really use equal signs, or dollar signs in the equation. 2010. Okay, so that's one equation. But then they tell us when we go back, we realize we don't have enough, so we go back. So now we have 4 bags of balloons, plus 8 rolls of streamers, equals $12.80. Now this is set up perfectly to use elimination, and that's what we could do. You can practice this if you want a couple extra practice problems. In a second, I'm going to give you the solution. If you don't want to look, you can pause it and try it on your own. But our solution for this would be the balloons. Ultimately, and you would write this out in words, but I'm just going to do this to save time. Each bag of balloons would be $1.54, and I rounded to 2 decimal places since we're dealing with money. And each roll of streamers would cost approximately 78 cents. The main key in this is to try to be able to write the equation. Let's look at our second example. A sporting goods store receives a shipment of 124 golf bags. The shipment includes 2 types of bags, full-size and collapsible. Full-size bag costs $38.50 each. The collapsible costs $22.50 each. The total bill for all 124 bags is $3,430. How many of each type of bag is in the shipment? Alright, let's get rid of that. A. So, again, what am I looking for? They want to know how many of each type. So we're looking for an amount. So, let's again make X equal the amount or number of, I'm going to call it the full size. And then we're going to make Y equal the number of collapsible. These are bags. So, here's a total, 124 bags. So what types of bags give me 124? Well, if I take all my full-size bags plus all of my collapsible bags, I should get a total of 124 bags. Then they give us another total. They give us this money total. Okay? My total here. Well, how did I get my money total? Well, the number of bags times how much they cost. If I keep doing that, I'll get my total. So we know a full size costs $38.50 for each one. Plus, we get $22.50 for each collapsible, and that should equal my $3,430. This would be my system of equations. Again, it's set up pretty nicely for elimination, but it's also very easy to get X or Y by itself, and then ultimately do substitution. If you want some extra practice, again, try this. Our final answer should be we should have a total of 40 full-size bags and 84 collapsible. That's what you should get if you solve it. Let's look at our third example. Robbie Gould is a place kicker for the Chicago Bears. In 2011, he was successful on 65 kicks. He scored a total of 121 points. Field goals are worth 3 points, and extra points are worth 1 point. How many field goals did he make? Alright, so now this is just asking for one specific thing. But no matter what, I still have two variables here. I know he made two types of kicks. I'm going to say X is the number of, let's say, field goals. And if you're only looking for one variable, sometimes it's nice to make sure that variable is your X, because we tend to solve for X and we're so used to it that if I really wanted to find only one thing and I called it Y, there's a bigger chance that you would forget that. So Y is equal to the number of extra points. So again, let's look for totals. We had a total of 65 kicks. Well, we know those kicks were the number of field goals plus the number of extra points should equal his total of 65. He scored a total of 121 points. So this one, this category would be the number of kicks. This category would be points. How does he get points? Well, for every field goal, he gets 3 points. Plus, for every extra point, he gets an extra point. And this, again, you can either do elimination or it's actually there's the X, the Y, and the Y are very easy to get along due to substitution. Again, if we were going to solve this, he ended up having a total of 28 field goals, and again, you would write 28 field goals, and 37 extra point kicks. And whenever you're solving a word problem, you would want to write your answer in words. But again, I'm just saving a little bit of time since our main goal here is just to be able to write the equation. But we would have 28 field goals and 37 extra points. And let's look at our last example. The senior classes at GGS and DGN planned a trip to New York City. DGN filled 1 van and 6 buses with 372 students. DGS filled 4 vans and 12 buses with 780 students. If each vehicle is filled to capacity, how many students could each hold? Alright, and what they mean by how much could each hold, they mean between the vans and the buses. So I'm going to hit say X equals, okay, the number of students on a van, or in the van, and then say Y is equal to the number of students in a bus. Now you don't have to use the variables X and Y. I just tend to find out it's a lot easier, especially if you think about our other lesson when we talked about actually using a calculator to solve. And if you use X and Y, it's much easier to put the slope-intercept form for your calculator, or at least to understand which variable is which. So let's look for some totals. We had a total of 372 students. So where did that total come from? Well, it came from 1 van and 6 buses. So the number of students in 1 van, okay, well, if we have 1 van, so 1 times the number of students plus 6 times the number of students in a bus should equal a total of 372 students. DGS had 4 times the number of students in a van plus 12 times the number of students in a bus should equal 780 students. And again, the X is really easy to get by itself, or you can use elimination, whichever one you choose. Unless I ask you to use a specific method, you can use any method you like. If we're actually going to solve this out, just to give you some extra practice, we would have figured out that the number of students in a van, each van can hold 18 students, and each bus could hold 59 students, and that's how you list it. Vans can hold 18 students, buses can hold 59 students. So hopefully you feel a little bit better.